Good day everyone, I am April Joy Licabo from BSFT 1A. Today I will be presenting our lesson titled Counting Particles in a Substance, the mole concept. This lesson will help us understand how chemists count extremely small particles like atoms and molecules. Here are our objectives. First, to understand the meaning of mole and molar mass. Second, to learn how to convert between grams and moles. Third, to know the importance of mole and molar mass in chemical calculation. And last, to apply this concept in solving simple problems. In introduction, in chemistry, we need to calculate the amount of reactants and products in reactions. But since atoms are extremely small, we cannot count them individually. That's why chemists created the mole, a unit that makes counting particles easier and more practical. Just like we use everyday counting units, such as 1 pair equals 2, 1 dozen equals 12, and 1 gram equals 500 sheets. Chemists also uses a grouping unit. But instead of 12 or 500, chemist uses a bigger number to count particles. So, what is a mole? A mole is an SI unit used to measure the amount of substance. The term mole means massive heap. So, 1 mole contains 6.022 times 10 raised to the power of 23 particles. This is called Avogadro's constant. A mole can also be defined as a number of atoms in 12.01 grams of carbon. Just like 1 dozen always equals 12, 1 mole always equals 6.022 times 10 raised to the power of 23 particles, no matter what substance it is. So let's look for the first example. We need to find how many molecules are in 4.0 moles of carbon dioxide. So we use the conversion 1 mole equals 6.022 times 10 raised to the power of 23 molecules. So 4.0 moles multiplied by Avogadro's constant is equals 2.41 times 10 raised to the power of 24 molecules of carbon dioxide. So next, how much is in a mole? Different substances have different molar masses. For example, 1 mole of carbon weighs 12.01 grams, while 1 mole of sodium weighs 22.99 grams, but both contains the same number of particles, which is 6.022 times 10 raised to the power of 23. So in calculating moles and number of atoms, here is another example. Aluminum is used for bicycle frames. If we have 10 grams of aluminum, let's compute the number of moles and number of atoms. So to find moles, we divide the mass by the molar mass. So 10 grams divided by 26.93 grams per mole is equals 0.371 moles of aluminum. So to find the number of atoms, we multiply the moles by Avogadro's constant. So 0.371 moles times 6.02 times 10 raised to the power of 23 gives 2.23 times 10 raised to the power of 23 atoms of aluminum. So, molar mass is the mass of 1 mole of a substance. It is measured in grams per mole. The molar mass is the same as the atomic or molar mass but expressed in grams. To find the molar mass of carbon monoxide, we add the atomic mass of carbon, which is 12.01 grams per mole, and oxygen, which is 16 grams per mole. So, the molar mass of carbon monoxide is 28.0 grams per mole. So, in methane, there is 1 carbon atom and 4 hydrogen atoms. So hydrogen has a mass of 1.008 grams per mole. Multiply that by 4. So carbon has a mass of 12.01 grams per mole. When we add carbon mass and hydrogen's total mass, we get 16.04 grams per mole for methane. Finding number of moles. To find the number of moles, we use the formula moles equals mass divided by molar mass. For example, 24 grams of carbon divided by its molar mass, 12 grams per mole, is equals 2 moles. So, after finding the number of moles, we multiply by Avogadro's constant to get the number of particles. So, 2 moles of carbon multiplied by 6.02 times 10 raised to the power of 23 is equals 1.204 times 10 raised to the power of 24 atoms. So, next, the mole relationship. So the mole is very important because it connects all chemical quantities, chemical reactions, solution, and atomic counts are all expressed in moles. That's why understanding the mole helps us solve many problems in chemistry. So in summary, we learned the meaning of mole and molar mass. We practiced conversion grams to moles, and we understood why these concepts are important. And lastly, we solve examples using the mole concept.